In this lesson, we're going to talk about the many different kinds of classes that Android gives you to help you build good-looking and effective user interfaces. In particular, I'll start by introducing the View class, a basic building block for just about everything that's visible on your device's screen. I'll also discuss the various events that views can receive. After that, I'll discuss a higher-level compound view called view groups, which combine multiple views to create a particular look or behavior. I'll also discuss some specific view groups, in particular adapter views and layouts. And after that, I'll talk about menus and the action bar, which give users easy access to frequently used functions. And last, I'll finish up with a discussion of dialogues, those views that pop up in front of an application to give and get information to and from the user. So let's talk about user interfaces or UIs in general. First of all, a user interface is essentially the place and the means by which the user and the application exchange information. And in this lesson, when I talk about a UI, I'm specifically going to concentrate on the device screen and the visual elements that users can see and touch on that screen. But of course, modern user interfaces can be much more than just that. For instance, handheld devices typically have many sensors, so user interfaces increasingly leverage many different kinds and qualities of input and output, including audio, LED lights, radio waves, and more. Now, getting back to Android, as I've said before, activities usually display a visual user interface to the user. So Android provides a rich set of classes from which developers can create those user interfaces. Let's talk about some of those classes, starting with the View class. The View class is a key building block for UI components. Views occupy a rectangular space on the screen, and they're responsible for drawing themselves and for handling any events that are directed to them. Android comes with a number of predefined or built-in views. Let me talk about a couple of them. Specifically, I'll talk about buttons, toggle buttons, checkboxes, the rating bar, and the autocomplete text view. So we've seen lots of buttons already in this class. A button is just a view. It's usually a somewhat small view that users can click on to start or to perform some action. Let's see one in the UI button application. As you can see, it's called UI button, and it has a single button at the bottom of the screen. And that button is labeled Press Me. And if you give in to the temptation and press the button, you'll see that the label changes and now says Got Pressed, followed by the number of times that button has been pressed so far. So I'll press it a few more times, and you can see that the count continues to rise by 1 each time that I press the button. And by now, you can probably guess what the code for this activity looks like. In fact, you've seen lots of examples in previous lessons that do things just like this. The code for this activity has created a button object, and it's attached a listener to that button. And every time I press this button, Android promises to, and in fact does, call the button listener's onClick method. Let's look at some more built-in views, and then I'll stop and give you some time to look at the code for each of the sample applications. The next view is called a toggle button. A toggle button is another kind of button. However, it also has the extra property that when you press it, it stays pressed. And it stays pressed until you press it again. So a toggle button is always in one of two states. It's either checked or it's not checked. Toggle buttons also typically display some kind of indicator to let the user know what state the button is currently in. And you've probably seen toggle buttons like this in many applications such as music players. You hit the button and the music starts playing. And it continues playing until you hit the button again. Let's see a toggle button in action. The application starts up and shows a single unchecked toggle button labeled Start. Under the label there's a small area. It's not lit up right now, but it will light up when the toggle button is eventually checked. So the idea here is that something's going to start happening when the user presses this toggle button. So I'll hit the Start button now, and what happens? In this case, the background color changes from black to white, and the toggle button now says Stop. You can see there's also a small blue highlight underneath the label, which indicates that the toggle button is now checked. The next view I'll talk about is the checkbox. You've probably seen things like this in many applications. Things like order forms, where, for instance, you check all the toppings that you want on your pizza, or something like that. Now, a checkbox is actually just another kind of two-state button, just like a toggle button. The main difference is just what it looks like to the user. Checkboxes usually display some kind of area that's empty when the checkbox is not checked, but shows a check mark or an X symbol or something like that when the checkbox is in the checked state. Let's see a checkbox in action. The application starts up and, going from top to bottom, displays some text and then an unchecked checkbox followed by the words, "I'm not checked." And then, underneath all that, there's a button that says Hide Checkbox. Now, I'll click on the checkbox. And as you can see, it displays a check mark to show that it's now been selected. You'll also notice that the text following the checkbox has changed to say, "I'm checked." And as you can imagine, in the source code, I've attached a listener to the checkbox, which changes that text to reflect the checkbox's current state. Now, I'll click on the Hide Checkbox button. And when I do that, the listener attached to the button changes the visibility of the checkbox so that now it's invisible. When I click on the button again, the checkbox becomes visible again. And again, when we take a break, please walk through the code for all of these sample applications to get an idea or see the different ways that views can be manipulated. The next view is the rating bar. This view displays a row of stars like you might use in an application that rates restaurants or songs or things like that. You know, it's great, I give it 5 stars out of 5. Or, oh, that's awful, I give it 1 star out of 5. The rating bar allows users to highlight some number of stars by clicking or dragging on the rating bar view. Let's see an application that uses a rating bar. Now I'll start the UI rating bar application. I've set up the rating bar to show a total of 4 stars, all unselected at the beginning. Now I'll select the first star, and as you can see, it highlights. Now the second star, and now the third. And now I'll drag back across the rating bar, which essentially deselects all the stars. And the last view I'll talk about is the autocomplete text view. This view is, first of all, a text view. That is, it's a view that displays text. And we've seen lots of those already. This text view is also editable, which means that users can type text that will go into this text view. And in addition, this view will show a list of text entries and will filter that list as you type, so that it only shows those entries that match what you're typing. And once you've narrowed down the list, you can touch a single entry, which will then be placed into the text view. Let's see that in an application. This application shows the words country. And then next to that, there's an autocomplete text view. And I've associated a long list of countries with this autocomplete text view. And now I want to have the name Chile appear in this box. Now I could have put the list in some kind of scrolling view, but then I would have had to keep scrolling through the long list to find the country that I wanted. With an autocomplete text view, however, I don't have to do any scrolling. I can just start typing in some letters. For instance, here I'll type the letter C, and now the letter H. And as you can see, there's a drop-down list that has appeared, showing only those countries that start with the letters CH. So in this case, there's Chad, Chile, China, and the Christmas Islands. So I'll continue by typing the letter I. And now the list has shrunk to just Chile and China. And I'll go ahead and type one more letter, L, and now there's just the single country, Chile, and that's left in the drop-down list. So I'll just select it now, and as you can see, the word Chile has been inserted into the autocomplete text view, and a little message window pops up confirming that I've chosen Chile. So those are a few of the views that Android provides. And the example applications showed some of the operations that are commonly applied to views. For instance, the UI checkbox application changed the visibility of the checkbox. The UI toggle button and UI checkbox applications changed the check state of the view. And also all of the examples used listeners in various ways to take some kind of action once the user had manipulated the view. In your own applications, of course, you'll put your own application-specific code in those listeners. And there are also many other view operations that we didn't show. For instance, you can set a view's opacity or transparency. You can set its background, its orientation on a display, and other things. And you can also have your views interact with the keyboard by requesting or accepting the input focus, which tells Android that keyboard clicks, for example, should be sent to a particular view. Views handle events, and these events can come from various sources, including the user, when he or she touches a view on the display, or uses physical input devices such as a physical keyboard, trackball, or D-pad. Android itself can also be a source of events. For instance, views receive various method calls when Android needs to reposition or redraw the views. Let's talk a bit more about view events. As we've seen many times already, a very common way to handle events is by attaching listeners to individual views. Android defines a number of different kinds of listener interfaces, and the methods defined by those interfaces get called when specific events occur on a view. For example, the view class defines an onClick listener interface that has an onClick method. This method is called whenever a view has been clicked. The view class also defines the onLongClick listener, and that has an onLongClick method. And this method is called whenever a view is pressed and held pressed for a specific period of time. The view class also defines an onFocusChange listener that has an onFocusChange method, and this method is called when a view has received or lost focus. It also defines an onKeyListener interface that has an onKey method, which is called when the view is about to receive a hardware key press. And there are many other events that you can listen for as well. So let's step back for a second. Right now, we're talking about individual views, but applications typically involve many views all being displayed at the same time. As we saw when we used the UI hierarchy viewer in our lesson on the Android development environment, an application's views are typically organized as a tree. Now there's some outermost view, and it holds some number of child views, and each of those child views can have its own children, and so on and so on. When Android goes to draw all of these views on the screen, it does so by walking through this view tree multiple times. each time doing something a bit different. So conceptually, on the first pass, it measures all of the views. On the second pass, it positions all the views. And on the third pass, it draws all the views. Now, much of the time, you don't worry or care about these steps. But if you create your own custom view subclasses, then you may also want to override these various view methods to ensure that your custom view is drawn the way that you want it to be. For instance, when it's doing its measuring pass, Android will call onMeasure on your view. And your view must calculate and then set its own dimensions. When it's doing its layout pass, Android will call your view's onLayout method. And this method should position itself and call layout on all of its children views. During the third pass, Android will call your view's onDraw method. And this method then draws the view. Some other methods you might want to override in your custom views include onFocusChanged to handle when your view's focus state changes, onKeyUp or onKeyDown to handle hardware key events, or onWindowVisibilityChanged to handle a change in the visibility status of the window containing your view.